Hi all. See this. This is a problem from three-dimensional geometry, and here it says that we are to find a point, right? And 159, right? So 159 is a point given to us, and a plane is given to us. So there is a plane and there is a point. This says that if we measure the distance along another line x equal to y equal to z, then what is the distance? Okay, so basically it says that how we measured the distance. Now observe that given point 1 minus 5 9 is definitely not lies in the line x equal to y equal to z. Why? Because in that line the x coordinate, y coordinate and z coordinate must be equal, right? So that's a very simple thing. So therefore we will say that here we have, when it says is measured along the line, that means we have to measure along the any parallel line through the point 1 minus 5 and 9. That's the concept. So first let's go ahead and observe the situation. So here we have a plane x plus y plus z, x minus y and z equal to 5 and all that stuff, and we have a line, right? We are having also a point here. Let us consider that point. Okay, so if I consider the given point as 1 minus 5 9, it will be somewhere here, right? So let's consider the point here. Okay, by default, right? Now it says that we have to measure the distance. Measure the distance means we have to draw a parallel line through this x plus y plus z. So let's draw a line parallel to the given line x equal to y and x equal to z. So let's go ahead. So obviously it will intersect the plane at some point. Let us assume that it's q, and we are required to find out the distance pq. Okay, so that means that, right, that means that our aim is to find the coordinate of the point q such that, right, this can be solved, right? So how we go ahead and find that point q? So the first option is that we have to look for the equation of pq. So if we are able to find the equation of pq, then we can understand that the point of intersection of a plane and a straight line. Okay, let's go ahead. Now see that here for this particular problem, the pq line is actually passing through. So the line pq is passing through the point. So it's passing through the point P, that is 1 minus 5 9, and parallel to x is equal to y is equal to z. So what's the equation? The equation of the line PQ is definitely be x minus 1 divided by 1 is equal to y plus 5 divided by 1 and z minus 9 divided by 1. Why? Because the direction cosine or direction ratio is the accurate right word. It's actually 111, right? That a vector of x, y, z along any vector, that is 111, right? Now, why I called it as direction ratio? Because if I square root it, right, that 1 square, 1 square and 1 square, it's root 3. So it's not a unit vector. So direction cosine must be a unit vector. But here it's not required. Any vector for a straight line, it works if it is we write down in this Cartesian form. So here we go ahead and let us assume these values are lambda. So therefore it's imply that x is equal to 1 plus lambda, y is equal to minus 5 plus lambda, and z is equal to 9 plus lambda. Now this is the xyz. Now this point xyz definitely lies, right, on the straight line. So therefore we'll say that the point 1 lambda, minus 5 lambda and 9 lambda is be any point on the straight line PQ. So let's write down. That's imply that 1 plus lambda, minus 5 plus lambda, 9 plus lambda lies on PQ. Now that same point P lies on PQ also lies in the point x minus y z. So let us assume that this only lies on x plus minus y and z. So therefore forcefully we substitute this point in that plane so that we can go ahead and find some particular values of lambda, so that we are able to calculate the value of the coordinate of q. So let us go ahead and say that let that point. So 1 plus lambda minus 5 plus lambda and 9 plus lambda lies on x minus y plus z, and that's equal to 5. So that's definitely imply that 1 plus lambda plus 5 minus lambda plus 9 and plus lambda, that's equal to 5. So if I calculate, we can see that lambda is e plus because 1 lambda get cancelled, we have 6, 15. That's equal to 5. That gives me lambda is equal to minus 10. So if lambda is equal to minus 10, this point lies on that coordinate plane, or sorry, lies on that particular given plane. So therefore we'll say that coordinate of PQ is actually lambda equal to minus 10. So you have to substitute the value here now. So the point Q, we can easily say that it's equivalent to, if lambda equal to minus 10, so it's 1 minus 10 minus 5 minus 10, and then we have 9 minus 10. So that means that this point can be written as minus 9, minus 15 and minus 1. So this is the point lies on Q, right? Now what we ask for? We ask for that the distance PQ. Now how we find the distance PQ? To find the distance PQ, you just now have to use the distance formula. So let's go ahead and apply the distance formula. Therefore we calculate PQ square. So what is PQ square? Minus 9 minus 1. So that gives you actually minus 9 minus 1 whole square plus minus 15 and minus of 5. So plus 5 whole square. And then we have 9 plus 1, so minus 1 plus minus 9 whole square. So every values, we can easily observe that every values gives me 10 here. So therefore we can say that it gives you 10 square plus 10 square plus 10 square. So therefore it gives you me that 10 square multiplied by 3. So therefore that PQ, it became 10 root 3, and that's why the distance are 10 root 3. So therefore for this particular problem, it is obvious that option B is the correct option, and that's it. So that's the problem. Hope you understood it. Thank you.